everyone, this is the proof for problem 10 in homework 8. So in this problem we want to show that if xt is normal process and it is white side stationary, then we want to prove that it is strict side stationary. So firstly, what we want to show is that, so by the definition of strictly side stationary, we want to show that the probability of x1, xn, t1 to tn should be equal to the probability of x1, xn on the condition that shift the time with optional. So if we can show this formula, then we'll finish the proof. So firstly, we'll write down the probability distribution for the normal process. It should be the t1 to tn should be equal to 1 over the square root of 2 pi to the power of n times the square root of the covariance matrix times the covariance of the determinant of the covariance matrix times the exponential of -1 over 2 times x minus eta. Eta is the expectation, so it is the mean, times the inverse of the covariance matrix times x minus eta. So where the covariance matrix should be the expectation of x minus eta times x minus eta transpose. So by the probability of white side stationary, we know that eta is a constant, so the mean is the constant, and the covariance matrix should be determined by the t2 minus t1. So it should be, so if we it should be equal to the rt1 t2 minus the square of eta rt1, so it is t1, t2 minus eta square to rt1 tn minus eta square, and this is rt2 t1 minus eta square rt2 t2 minus eta square to rt2 tn minus eta square, and this is rtn t1 minus eta square rtn t2 minus eta square to rtn tn minus eta square. So this is the covariance matrix. So by the probability that the xt is white side stationary, so this can be written as, this is t1 minus t1 is 0, r0 minus eta square, and this is t2 minus t1 minus eta square to rt, so it should be, yes, this should be tn minus t1 minus eta square, so there should be rt1 minus tn minus eta square, and rt2 minus tn minus eta square, so to r0, tn minus tn is 0 minus eta square. So we know that the covariance matrix only determined by the difference between different times. So it should be C T1 minus T2 to T1 minus T3 blah 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 T1 minus Tn. So and T2 minus T1 to Tn minus T2 minus Tn. So blah 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 until Tn minus 1 minus Tn. So this can be written as Ti minus Tj, where I is not equal to j, for I and j is arbitrary chosen from 1 to n. So therefore, the probability can be rewritten as fx xe to xn Ti minus Tj, for I is not equal to j and I and j are arbitrarily chosen from 1 to n. So therefore, we can write the switched form probability distribution as Tn plus epsilon as x1 to xn. So it should be Ti plus epsilon minus Tj plus epsilon, where I is not equal to j and ij are arbitrary chosen from 1 to n. So here the epsilon can be removed. So therefore it should be equal to x1 to xn and Ti minus Tj. So I is not equal to j and ij are arbitrarily chosen from 1 and n. So therefore this is exactly the same with this one. So it should be equal to x1 to xn, T1 to Tn. So therefore we have already finished showing this property, and the stationary process xt is strictly wide stationary. So we have finished the proof.